Previously on the Aruba switching story, we've learned about the Edge Services platform and how Aruba switching fits into the unified infrastructure portion of the Edge Services platform. We've set up our workflow where we're going to try to connect a security camera into the campus edge to be able to access a facial recognition application in the data center. So we've used the Aruba Fabric Composer to be able to provision that data center. We've learned about data center bridging and how that can help with Aruba data center switches. We've looked at how to do different provisioning methods for infrastructure deployment in the campus to get the network ready to set up to plug the camera into. Now it's time to plug in the camera. So in this video, Daryl Wan is joining me to talk more about onboarding devices and applying Aruba's dynamic segmentation solution in the campus network.
Thanks, Justin. We've talked about how devices get power already. So how do we handle new devices in the access layer?
Well, as we can see here from the topology that I'm showing, so when preparing onboard devices, we don't want a device to have full access to the network. So we have our devices here. We don't want our devices to have full access to the network when plugging it into the switch. So to prevent unauthorized access, we recommend that we authenticate every device that plugs in to the switch. And so one of the solutions that we have at Aruba is this notion of colorless ports. So traditionally, ports and ACLs on a switch were configured statically across all the switches in a campus network. Maybe it even assigned a color. So for example, red ports would be access ports, blue ports would be laptops, and so forth. So each block of ports would have VLAN assignment, port attributes, and ACLs or policy applied to it, which would lead for large lines of ACLs and policy throughout the switch. Consequently, if a technician were on site and plugged in a device into the wrong port, it would get the wrong access and configuration, potentially making it hard to troubleshoot. So with colorless ports, we can eliminate the so-called quote-unquote colors by authenticating all devices with either 802.1x, if the device supports supplicants, then 802.1x supplicant, or MAC authentication. Typically, MAC authentication would be used for headless devices or IoT devices that don't have a built-in supplicant. So this is important as we have more and more devices that plug into the networks and are plugging into the switch, as we have PoE lights, as Yash is going to talk about later, medical devices, monitors. There's all these devices that are going to be plugged into the wired network and need to securely authenticate. Combining MAC authentication with these devices and the advanced profiling capabilities of ClearPass, this allows for a more secure authentication. So once a device is authenticated at the access layer, we can then assign a user role to that user or device.
What exactly is a role, and are there different types?
So a role contains these various port attributes that used to be statically configured. So it contains port attributes, VLAN assignment, QoS, or security policy for a device or user. So to answer your question, yeah, there are two types of user roles, local and downloadable. So a local role is where the role configuration exists on the switch that the role will be applied to. So say, for example, our camera role, if we're plugging in the same type of camera into multiple switches, that role has to exist on each and every switch. A benefit of using ClearPass is the downloadable role. So in this feature, the role configuration exists in ClearPass and is downloaded to the switch dynamically when the client is authenticated and in session. So no matter where a device is plugged in across the network, it'll get the same role and policy, eliminating the need to configure these thousands of lines of ACLs on switches and preventing user error. So let's take a look at what this looks like in ClearPass. This is an example of a role in ClearPass. This is what the role syntax looks like as it would be applied on a switch if it was local, but in this case, we're using a downloadable role. So what you'd have is you have your classifiers and your policy, as well as your VLAN assignment that the client or user will have applied to it as the device or user is authenticated. So this is the exact same syntax that would exist on a switch in a local role if we're using local roles. In this case, we're using a downloadable role. So when you're using downloadable roles, the user or device authenticates, and then the role is downloaded to the switch via the REST API dynamically as the client is authenticated successfully.
I've heard a lot about dynamic segmentation. How do roles and colorless ports fit into the dynamic segmentation solution?
So a role is part of the colorless port solution. So colorless ports makes up the dynamic portion of our dynamic segmentation solution, but colorless ports can also work independently of dynamic segmentation. So colorless ports doesn't equal dynamic segmentation, it's merely a part of it. And we don't need dynamic segmentation to run colorless ports. So however, colorless ports can also work independently of dynamic segmentation, and the role can also direct what the client can do with the traffic.
Oh, really? So what can the role do with the traffic?
Well, let's go back to our topology here. So as part of our topology, the role allows us to direct traffic to the client. So we have multiple clients here, each in its own separate VLAN, each getting its own unique user role. So we have three ways of currently handling traffic within a role. So we can dynamically assign traffic to a local VLAN at the access switch. We can use that same exact method as assigning a local VLAN to also have that VLAN pre-provisioned to a VNI, and then we can dynamically assign user traffic into a VLAN that's part of a VNBT infrastructure, which is based on VXLAN and EVPN. So then we can tunnel traffic switch to switch as shown here in this VXLAN overlay tunnel. So VNBT is basically VXLAN and EVPN with policy on top of it that we dynamically assign using user roles. Or we can tunnel the traffic to an Aruba gateway cluster, which is what we call user-based tunneling. So both VNBT and UBT, or virtual network-based tunneling and user-based tunneling, are part of dynamic segmentation. They make up the segmentation portion of that. So in our topology, we have a camera and a laptop placed into both user-based tunnels and virtual network-based tunnels. What we're talking about overall in this segment of videos is our security camera here using VNBT that is accessing the facial recognition application in the data center. That's all over a VNBT tunnel.
Can you explain some of the benefits of UBT?
So with UBT, that works off the colorless ports story as I just mentioned. So if we take a look at NetEdit, NetEdit is our configuration management tool for our Aruba CX switches. So we're moving a lot of the NetEdit functionality into Aruba Central, as we saw in an earlier video, that Central has now the multi-editor feature in Central 2.5.3. But NetEdit also does some validation checks, as well as we can manage switch configuration using NetEdit. We can also use the topology view here, as we see, and look at the overlay tunnels as part of our network topology. So here, this red tunnel is our user-based tunnel. So this is the tunnel between our access switch and our mobility gateway cluster. These tan colored tunnels are switch-to-switch tunnels, or VNBT tunnels. So those are indicated by we can see that's going switch-to-switch into our pair of data center switches. So focusing on UBT, like the case of the camera authenticates at the switch here and then goes over the tunnel here to the gateway cluster. Now, NetEdit can also allow us to quickly configure solutions such as dynamic segmentation or specifically UBT. We click on our access switch, we can go to our deploy solution wizard, and then that will automatically bring up a wizard that we can quickly configure user-based tunnels on a single switch or multiple switches. NetEdit allows us to configure either a single device or multiple devices at the same time. So some of these built-in wizards that we have, we can quickly enter the values, the desired values for that, and then push that configuration to the switch.
So that's great for UBT. What about the benefits of VNBT?
So VNBT, or virtual network-based tunneling, is a little different. It's based on VXLAN and EVPN. With VXLAN, authentication is not required. Ports can be assigned to VLANs that are tied to VNIs, and the traffic from those ports is automatically placed into the VXLAN tunnel. So where VNBT comes in is the ability to securely onboard and authenticate the devices and clients using user roles. The user role will have the VLAN assignment that is tied to the VNI, so then clients are now dynamically placed into the VNBT tunnels, which is indicated here by these tan-colored tunnels. So also policy in the user role can be applied to restrict traffic between VNBT tunnels. So if we go back to ClearPass, we can see here we have an ACL as part of our user role policy that will restrict tunnels, or will restrict traffic between the VNI 101 and VNI 102 tunnels with this client. So how we can configure VNBT in NetEdit is we can go back here to NetEdit, and we can, as I mentioned, NetEdit allows us to edit the config of a single switch or multiple switches. We can open the configuration editor, and the important items that we want to make sure are configured when we're configuring VNBT. Our first is our EVPN configurations. We want to make sure we have the correct VLANs configured in our EVPN configuration. We also want to make sure our SVIs are configured correctly. So if we come down here to, we're using VLAN 101 as we showed in our diagram. So if we come here to interface VLAN 101, we want to make sure we have the correct SVI configured. As well as we want to make sure we have our VNIs and VLANs configured in our VXLAN interface, as we can see here. So then once we're configured, it's fairly simple to do. We have documentation on that. Once we have that set and ready to configure and configured here in the editor, we can then push the configuration to a switch. So when we're going back to NetEdit, when we're making changes in NetEdit, we're actually just making changes against a copy of the configuration. And as we're making changes in the editor, it's not affecting what's running in production until we deploy the plan that we've created. So every time we make a configuration change in NetEdit, it creates what's called a plan. And so every time a change is made, a plan is created, even if the change is made outside of NetEdit. And then that's indicated in the plan log as it's done by the system. So then once we're finished with our VNBT configuration, we can then push this configuration to the switch. So one use case for VNBT might be what we're talking with our overall story here among this video series, is that we have a security camera that needs to access an application in the data center. So for this instance, we're accessing a facial recognition application. So throughout this video series, you've seen the data center provisioned. We've provisioned our campus switches. We've learned, or we're going to learn more about in depth with CX. But for now, we need to plug in our camera. So we've learned about dynamic segmentation and preparing for that and how we can authenticate the camera. And then once it's applied into the VNBT tunnel, we can then go back and make sure that our facial recognition application is working. As we see here, we have our friend Matt, who's been recognized as Matt in the Hat in our video. So now we have the complete story from the edge to the data center.
That's great. So what are the differences between UBT and VNBT?
So some of the differences between UBT and VNBT is that UBT, or user-based tunneling, requires authentication. VNBT or VXLAN tunnels do not, or VXLAN tunnels do not. We can statically assign ports into VXLAN. But if we want to use the user role capabilities, combining VXLAN with user roles, authentication will be required.
That's great. Final question. Can both UBT and VNBT be used at the same time?
Absolutely. As we can see here in our diagram, and as we just saw in NetEdit, we have both VNBT and UBT running at the same time concurrently. Thank you, Daryl, for helping me explain how Aruba's dynamic segmentation solution can help securely onboard devices, as well as be able to fit into our workflow, where now our camera can plug in securely and be able to access the data center using a VNBT tunnel. In our next episode, Yash and Kamal Takodra, both technical marketing engineers, will talk to us more about the advanced capabilities of PoE in Aruba CX switches, specifically with always on and quick PoE. So please don't forget to tune in for that episode.